Okay, we'll quickly look at question 10. First question in section B. Big question, 19 marks. Talking about the function e to the x cos x. So part A, find an expression for dy dx. So straightforward use of the product rule. You can write it down. I always like to write u equals e to the x, v is equal to cos x in this case, and then write down my terms. Put it together and get that. Part B, show that the second derivative is equal to the result that's given there. So here we go again. It's a product rule again. I think it's a little bit easier here if you factor out e to the x. So this then becomes a product with u equal e to the x, and v is cos x minus sin x. Will lead you through to the required result. So I'll leave you to check the algebra there. So our second derivative equals minus 2e to the x sin x as required. Then it takes us into the function and starts. First of all, it sets a domain, so I need to be aware that I'm talking about minus pi on 2 less or equal to x less or equal to pi on 2. Find the x-coordinate of the local maximum. So yeah, I set the first derivative to 0. So here I go. E to the x is not 0, so cos x minus sin x must be 0. Remember that the identity tan is sine over cos will solve questions of this structure. So tan x becomes 1, and x then becomes pi on 4. In the domain that I'm talking about, I know from minus pi on 2 to pi on 2, I'm only going to have one solution there. So x is pi on 4 is my answer for C. D, then to sketch the graph of the function. I know that there's only one turning point, so I've got that there. I know also that it's going to be 0. If I put e to the x cos x is 0, that's going to be 0 at pi on 2 and minus pi on 2. I can comfortably find the y-axis intercept by substituting in x is 0. X is 0, it's the original function. E to the 0 is 1. Cos of 0 is 1, so I know that that intercept is at 1. So there's my sketch of the function that we've got. Marks given, one for the appropriate domain, one for the shape, one for the intercepts, and one for the maximum point there, which I can work that out, of course, by substituting x is pi on 4 into the original function. So I've got all the information on my sketch there for my 4 marks. E, find the sketch of f of the absolute value of x. Now this is the transformation whereby I take the positive part and it then gets reflected. So you end up with a graph that's symmetrical in the y-axis there. And of course I can just transfer across the information, the intercepts, pi on 2, 1, 1, and the maximum at pi on 4. Of course now I'm going to get another maximum here at pi on 4. So remembering what transformation that function gives. Then part F, calculate the area enclosed by the graph that you've just sketched and the axis. So of course I'm going to exploit the symmetry. I'm going to find this area and multiply it by 2. So I set that integral up. 2 lots of the integral from pi on 2 of the function. And this is a part question. Integration by parts. I'm going to set it up. It doesn't really matter which way you set up here. It's one of the questions where you need to go by parts twice. So I've got my parts working out down the side here. I know that if I set e to the x to be u in the first time, I have to do it the same the second time. So there's my parts once, there's my parts again. That will lead me through. I'll leave that working there for you just to hit pause and follow through if you need to. Once I've got that integral sorted out, I can put it into my area question, 2 lots of that integral eventually becomes e to the pi on 2 minus 1.